Hello class, so today we're going to be discussing the properties of multiplication. So if you haven't already pulled this up, pause this video, either upload it into Kami or print it out so you could take notes while I'm talking. Once you have done that, restart this video. If you already have it, then let's continue. So first we're going to talk about the identity property. What is the identity property? This means that any number times 1 has a product of itself. So product, remember, is the answer to our multiplication problem. Just like an answer to an addition problem was a sum, the product is the answer to a multiplication problem. So this is saying that if I take any number, no matter how big it is, and I multiply it by 1, it's going to be the same number that you multiplied it by. So 1 times 10, it would be 10. 1 times a million, it would be 1 million. So I think it's important that we know that times 1 product itself. So I'm going to highlight that. Times 1, and then product of itself. Let's highlight the whole thing. Okay. I'm going to hit undo. Sorry about that. There we go. And so a variable example would be a times 1 equals a. So with a variable, you can fill in any number for that variable. So like my example, 1 million times 1 is 1 million. So we're going to do a number example over here. And we are going to try with 10 times 1. So we're going to write 10 times 1 equals 10. Since this is a quick one, we can do one more problem. So we can do 274 times 1 equals 274. Next, we are going to move on to the 0 property. This property is also very simple. So the 0 property is any number times 0 has a product of 0. So this time, 0, anything times 0 is going to be 0, whereas anything times 1 was going to be the anything. So I'm going to highlight times 0, product of 0. If you guys want to highlight, star this on your notes also, that would be great. So our variable example is a times 0 equals 0. So it's pretty self-explanatory that if you multiply something by 0, it's 0. So let's do a practice problem. So we'll do 50 times 0 equals 0. We'll do my favorite number, 33 times 0 equals 0. So moving on to the commutative property. So this is where things get a little more complicated, not too complicated though. So if you remember this from addition, where we would add, say 3 plus 4 is also the same as 4 plus 3. It's the same concept in multiplication, that 4 times 3 would also be 3 times 4. So the definition here says that changing the order when multiplying two numbers does not change the product. So it's saying that you can multiply any two numbers in any order and get the same answer. So I'm going to highlight here. Changing order and then does not change the product. So our variable example is a times b equals b times a. So we're going to go ahead and fill in numbers for this. So I'm going to zoom in my screen to make it easier to write on. There we go. So we have, we'll do, like I said before, 3 times 4 equals 4 times 3. 82 times 17 equals 17 times 82. Now we're going to talk about the associative property. So this is saying when we're multiplying 3 or more numbers, changing the order does not change the product. So this is very similar to the commutative property, but the commutative property is only with 2 numbers. The associative property is with 3 or more numbers. So when we're multiplying any of these 3 numbers, you can do it in any order, and it's going to be the same. So our variable example is A times B times C, or A times B times C. So let's highlight in the definition really quick. So multiplying 3 numbers, changing the grouping does not change the product. So the parentheses are really important, because if we remember PEMDAS, so or please excuse my dear Aunt Sally, we have parentheses, exponents, multiplication, division, addition, and subtraction. And so versus the parentheses. So we always start by multiplying what's in the parentheses first. So if we were doing A times B, we would first do B times C, and then the answer to that, so BC times A. That might be a little confusing with variables, but once we put in numbers, it will make sense. So going back to my drawing pen, so we're going to do 5 times, and then parenthesis, 7 times 3. And then, so what I was just saying was that with the parentheses, you would multiply what's in the parentheses first. So you would do 7 times 3, and then you'd get 21. And then you would be able to multiply 5 times 21. And it just makes things simpler. But to finish out this problem here, 5 times parentheses 7 times 3 parentheses equals parentheses 5 times 7 parentheses times 3. So I'm going to show you an example of how this property can be really helpful. So say we are multiplying 9 times 4 times 25. And our parentheses are around the 9 and the 4. We know that 9 times 4 would be 36, and then we'd have to do 36 times 25. This is a big problem for us to do in our head. I know I can't do it. I would need my calculator. But I wonder if we could rearrange it so we could do it in our head. So this is what we would use the associative property for. So we will do 9 times, parenthesis, 4 times 25. Now, we are able to do 4 times 25 in our head because that's 100, and we could think in terms of quarter, and we all know how to count money. So then we'd have 100, and 9 times 100, we could do 9 times 1, which is 9. We know that from the identity property, and then we add our 2 zeros, which is 900. So 36 times 25 is also 900, but we weren't able to do that in our head. But by just rearranging the problem, we are able to do 9 times 100 in our head. Lastly, we have the distributive property. This is when we multiply 2 or more numbers. We can split them up into factors to make it easier to solve. So we're going to highlight multiplying 2 or more. We can split up, and then you can do it into the sum and then multiply. So our variable example is a times, parenthesis, b plus c equals a times b plus a times c. So what we would do for this is, say we were multiplying 8 times 7, but say we don't know what 8 times 7 is in our head. But we do know that we could break apart the 7 into 2 numbers so that 7 would be the sum. So how can we break apart 7? We could do 5 plus 2. So then instead, we could do 8 times 5 plus 2. With the distributive property, I'm going to change the color of the pen. We take the 8, and we know we're going to have to multiply 8 by 5. Then we're going to multiply 8 by 2. So now we rewrite the problem as 8 times 5, which we know, which is 40, and 8 times 2, which is 16. 40 plus 16 is 56. And so now we know that 8 times 7 is 56. And so this property just helps us to break down problems, so it makes it easier to solve in our head. So those are the 5 properties that we're going to discuss today. There will be a few problems that I want you to work through, and I will. So I'm going to quickly go through a few problems with you at the bottom of this sheet. Let me zoom back out. So it's asking us to identify which property is demonstrated in the following problems. So we're just going to do a few, and then I want you to complete the rest on your own. So I'm going to add a text box here. So we know that anything times 1 is the identity property. So 1,475 times 1, this is representing the identity property. $75 times 34 equals 34 times 75. We discussed this above, that this is the commutative property. So if you need to refer to the notes above, you have that available, but I want you to complete the rest of these problems, there's 15, and submit them to me on Blackboard. Hope you guys have a wonderful day. Let me know if you have any questions.